Okay, you should be on page 23 for lesson 3. And once again, my TV hates me. I'm a poet. Ay, ay, ay. Here we go. All right. On the TV, do you see the page that you are looking at? Page 23. Some of you do. Some of you don't have your book open. Let's go, folks. You're 6th graders. Come on. Page 23. I am not your babysitter. I'm your math teacher. All right. Are we ready? Ta-da.
Thank you.
You're welcome. All right. We are once again doing ratios. Notice our model that we're using today. Tape diagrams. You guys remember tape diagrams from 5th grade? Okay. Yesterday we did a table. Today we're adding a tape diagram model. All right. Are we ready? All right. We are in a flower case at the supermarket. There are 5 bouquets of red roses. There are 4 bouquets of pink roses. Each bouquet is a half a dozen roses. How much is half a dozen? 6. Okay, so each bouquet has 6. Okay? So I'm going to put that number right there because we need that. Okay, so let's think about this. Each bouquet has 6 roses, right? There's 5 bouquets of red roses. There's 4 bouquets of pink roses. They want us to write and explain 2 ratios that could represent this. So, 2 different ratios. So I'm going to give you one ratio right off the bat. From the top, the ratio of red to pink is 5 to 4, right? Is that the easiest ratio there? Okay. Now, here's my question. Can I then say this is my second ratio? No. That is the exact same thing. That is just written a different way. That is the same ratio. Yes, ma'am. Okay, that is also the same thing. You can do 4 to 5. This is one ratio. That is one way. Okay? That is not 2 ways. That is one way. Another ratio could be 4 to 5. What did that person do differently? It's different. It's not the same. They flipped them. It's not red to pink now. It is pink to red. That is what is different. Do you see that? Okay. Okay, this has a big fat star beside it for a reason. I star stuff not because I'm artsy or because I like pretty things. Okay? I star stuff because it's on your exit ticket. Your exit ticket, question A. You have to write the ratio 2 different ways. Just like that. Ding, 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 ding. This is your first clue. Okay? If you're not writing down what I'm writing down and you're not watching what I'm writing, you're going to struggle. You're going to be on that struggle bus today and you're driving all the way home. Just saying. All right? The second part is the next part of the exit ticket. All right. How many was in each bouquet? Okay. So the last class struggled with how I explained it. So I'm going to explain it a different way. So if we have red here and we have pink here, I think this will be easier. And each bouquet, we have 5 red. 1, 2, 3, 4. Whew. Okay, like I said, guys, I am not the art teacher. 1, 2, 3, 4, 5. Okay, tape diagrams. My tape diagrams are the same size. Notice how the 5 on top and the 4 on bottom, the 4 below are the same size as the 4 above it? Okay. How can I make each of them have 6?
Putting like 6 dots in each.
Okay, what if I just put a number 6? Will that be better?
Yeah.
I don't want to put dots. That takes too much time. I'm lazy. Sorry. I'll admit it. I'm okay with that. I'm lazy.
That's actually just...
Yeah, I'm lazy.
That's just,
Yeah. I'm also not the teacher that makes you write full sentences for your answer. Like my math book, if you look at my teacher edition, it wants you to write these giant sentences. This whole part up here was write and explain full sentences. To me, that is an explanation. That tells me you did pink to red, right? That tells me you did red to pink. I'm perfectly fine with that because you showed me 2 different ways. I don't need full sentences. I'm not your ELA teacher.
like Mr. Juno.
Yeah, that's your ELA teacher, not me. Or Miss Brim. Those are your ELA teachers. All right? So, here we go. How many red roses do we have all together now? 30. And how many pink roses do we have all together now? 24. So we have some questions up here we need to answer. And I can't read them, so I'm going to open my book here so I can see what they say. So it says, each bouquet is an identical mixture of red and pink. How many bouquets can he make? How many red roses and how many pink roses are in each bouquet? He can make 6, right? So he can make 6 identical ones. And how many are going to be in each? 6 bouquets. And he's going to have 5 red. And he's going to have... whoopsie doopsie. 4 pink. Each bouquet is going to have that. Because you see all them boxes that have a 6 in it? I can take them boxes and I know I'm good. If I make all them boxes now worth 1, yeah.
It's going to take a long time.
Yeah. All right. So, once again, now we'll just use the same color. Now we'll use black.
Ratio language.
Black. Superstar. 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 That is letter B on your exit ticket. Letter B on your exit ticket. Ladies and gentlemen, Hint, hint, hint. Just a helpful hint from your teacher to look back at page 23 because, boom, that's going to help you because your teachers will not give you the answers.
Because it's so obvious that you do.
Yeah. We're your teachers, not your answer givers. I know giverers is not a word, but it's okay. All right. Ratio language. Ratio language. This is important because this is the same for every single one. Are you ready?
Not yet.
For every blank.
So, can I ask a question? If there is like a ratio that is 10, 3, and 3, when I do the ratio, if I do it 10 over 3, do I still need to do it as an improper fraction?
That could be your ratio, yeah. Or you could write 10 dot dot 3. There's different ways to write it, yeah. You can ask me those questions when you get to them, yeah. I just won't give you answers. That's a question, not an answer, yeah. All right, so on this one, that's the first part. So for every blank, there are blank. This is the one time I make you write a sentence because that is ratio language. That's what they want. And it is whatever the ratio is. So yesterday my example was apples and bananas. So yesterday I would say for every 3 apples there are 4 bananas. But today for every 5 red roses there are 4 pink roses. Those 2 lines are filled in with whatever your ratio is comparing. The for every and there are stays the same every time. Well, sometimes it says there is.
When I first ever heard of ratios, I thought it was like some sort of like marshmallow.
Hmm? You don't have to do it. All right, here you go. This, bing, 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 superstar. That is the 3rd question on your exit ticket. So, first page I taught you today is your exit ticket. Remember yesterday I said was the easiest lesson you will learn. It's only going to get harder. Every day gets harder. Okay, your exit ticket is always going to be a little bit harder than the lesson. Bless you. All right. Are we ready to go to the next page?
Yeah.
Okay. This is Bob, I think. We're naming him Bob. Bob got his picture taken. This printed photo has a width of 5 inches and a height of 7 inches. So they want us to draw a tape diagram for width to height. So I'm going to put my little width to height over here. I want my ratio so I can see it. I like to have a visual. Maybe you want to write it that way. I don't care. If you want to write it width to height, I don't care. I put the dots because that's how my mind sees ratios. All right, so tape diagrams. Remember, boxes are the same size. They're neat. It doesn't look like someone stepped on it and squished it. Same size. So if I have 5 and 7, the 5 on top and 5 of the bottom need to be the same size, and then there's going to be 2 more, right? So I'm going to do width and I'm going to do height. And that big box is going to be cut in half. And I got to break it into 5. Pretty close. Then I got to get 2 more down here at the bottom. Art is not my strong suit. Can you tell? A little bit? Yeah. I'll try to make it a little bit neater. That's a little better. All right. 5 and 7. So my width was 5 inches and my height was 7 inches, right? So what does each box equal? So each box, so I could put like, each box up here would be 5. The whole thing is 5. Each box is 1. So when it says, what does 1 unit in the tape diagram represent? Each box, that's talking about what is each box is 1 inch. Each box is 1 inch. So if you wanted to be nice and particular, you could draw a 1 in every single one of those boxes. But we don't have to because we know they're each worth 1, right? All right. They building something next door or what? All right, so we already did this. Width to height. Ratio of width to height. So we did that, right? Width to height. 5 to 7. So if you were doing this in 5th grade and you have the teachers that want you to restate the questions, you're going to have long sentences answering this. I just want to be able to see this is the answer. Width to height, 5 to 7. I'm good with that.
Yay,
we got more things to do.
Yay, I like this teacher.
Okay, you guys are lucky because you can still see the last page, right? So, now they're going height to width. So they're flipping it on us. It was width to height. Now we're height to width. What's the height? 7. What's the width? 5. So remember when we did this yesterday, height is first, width is second as a fraction. Height is first. What's the number? Second number? 5. Do not think because it's an improper fraction that it is wrong. On your exit ticket, when you had that 5 on top, you thought it was wrong over the 4 because it was an improper fraction. That does not make it wrong. It just makes it bigger than 1. Okay, now they want the ratio for the width of the photo to the perimeter. So, width to perimeter. So we know the width is 5. What does perimeter mean? Can somebody tell me what perimeter means?
The whole thing.
We got Bob here. Ooh, look at my art. Hi, Bob.
One side plus one side, one side.
Okay, so one side plus one side plus one side plus one side. So we got 5, 7, 5, 7. If we plus all those, add them all up, what is our total? 24. So our perimeter is 24. That is the extent of my artistic ability. That is why I am a math teacher and not a art teacher.
Did you want to be an art teacher?
No,
You
never,
wanted to be a math?
never. All right, so the next tape diagram is talking about older televisions. What are they showing us is the width of the TV. Okay, and what are they showing us is the height of the TV. 3, so 4 to 3. So I say width to height ratio. What am I putting? Whoops.
4 to 3.
That is an example of my mind working ahead of my fingers. Or my fingers working ahead of my mind, something like that. See, even teachers have ADHD. All right, so according to this tape diagram, what else could my ratio be if it's not 4 to 3? Nope. Width to height. Staying with width to height, but it's not 4 to 3.
4 to 2.
Nope, that's the same thing. Any ideas? We have to stay width to height, and it can't be 4 to 3. Nope, it's got to stay width to height. Nope. This and this and this is all the same thing. Nope, it's got to stay width to height. Okay. What if, that's the same thing. What if I do this? What did I just do? What are they now worth? 2. So what is my width now? 8. And what is my height?
6.
Okay. So I could have width to height of 8 to 6, right? So thinking along those lines, can you give me another one?
16, 12.
Woo! That works. That does work. Boys, look in here, not out the window. I'll close the blinds. Okay, you see that? All right. You can put any number in there. Older televisions weren't this big, but you know they got like the giant 72-inch screens now. Okay. Okay, last page. That was the last page. So, I'm not going anywhere. Here's what we do when it's the last page. Today's exit ticket is graded. So, here is what you do. You put your first and last name on the top of the exit ticket. When it is done, it is handed in for a grade. If there are any corrections to be made on it, it will be handed back to you. Any questions before we continue?
And then the exit ticket you have to answer by I just, okay, so it's no help.
No help on the exit ticket. No talking with your table partners on the exit ticket. It is you and you alone. Good luck.